Hello there and welcome. In this episode, we continue working on our resource gathering system. It will probably take us a few more episodes focusing on this system, and then we can continue with other topics. At this point, we can build our supply center. We also have a harvester, and we also have a state machine to allow the harvester to gather, to harvest, and then to deposit into the supply center. But we still don't have a way to assign a node. So if we construct our supply center and we click on the harvester, there is no way to actually assign the resource node, right? So we have the supply center, we have the harvester.
Awaiting orders. Of course, as you wish.
But we don't have a way to assign this node. And we can also see this from the inspector. The supply center is assigned automatically when we build it, but the assigned node is not assigned, so we need a way to assign it. So this is what we're going to do in this episode, and we're going to do a few more things. For example, make this resource node look a bit better. So before we do this, I want to change the camera a bit. So we click on the camera controller and then on the main camera. I just want to change the zoom level, because if we run the game, we can see that everything is very big. And if we build a building and then this supply center, everything is very large. And this is not something ideal for an RTS game. So let's create a bigger zoom. We can change the main camera zoom to, let's say, 25. And I think this is a nice amount. Now, if you change the field of view on the main camera, also make sure you do this for the cursor camera, because otherwise you're going to get different problems. So make sure you have the same value inside the cursor camera and the main camera. So I think that 25 is nice. Imagine we have enemies and more buildings, so you should have a larger area. And it's fine that the unit is very small, because we can have a lot of different units and we want to be able to see all of them. We want to be able to see all the buildings. So you can play around with the zoom if you want to. Later in the series, we can also add an option to zoom in and zoom out, but this is something we're going to do a bit later. Now, other than just allowing the harvester to assign this node and start working on this node and do this entire loop inside of the animator, right? Going to harvest, harvesting, going to supply center, depositing, this entire loop. We also want to take care of different situations. For example, if the harvester is taking part in this loop, but then we click somewhere on the ground and we maybe ask the harvester to move to a different place, then it should basically stop harvesting and break this entire loop. So at this point, this will not be possible, because if there is a node assigned, he will automatically go into this loop of harvesting and depositing. Maybe the supply node, the resource node, will be destroyed or be depleted. What will happen then? And we're going to take care of this by changing the way our harvester is moving. Because if we go into our harvester script at this point, we can see that we are moving it using agent set destination. But our harvester also has this generic unit movement script, and we move the agent inside of the script as well. So if we click and let the harvester move, for example, to the node, it will move it in both places and it will give us different problems. So we only want to move the unit inside the unit movement script, and over here we don't want to move the agent. Instead, we want to reference the unit movement script, and this way we're not going to have all of these problems. We also want to differentiate between when we assign a node and basically let the harvester move to the node, or when we click somewhere else. And by differentiating between these commands, we can let the harvester know when it should stop harvesting or when it should go to this node. And we can do this by simply providing another parameter when we move it inside the unit movement script. So if it's true, then we know that it's a player command. If it's false, then we know that it's a command that was made by the AI system, right? So to do these changes, we're going to open our unit movement script, and inside we're going to create a method, public void move2, and we're going to provide a vector tree position and also a bool that will help us differentiate if it's a player command or if it's a part of the state machine. And here we're basically going to take all of this code and cut it into this method. And we're simply going to use this position as the position for the agent to move, but we're still going to call these methods. Now you can also take these ones, the sound and the line, you can also add them inside, but we can just make sure this method is taking care of the movement. And then we also have additional movement actions. So now we can simply call this method over here. So move2, and we're going to provide a position, hit point, and also true, because we basically say that player command is true. So we are commanding it to move, right? Because here we are clicking on the right mouse or on the left mouse, and then we basically command the unit to move. So this time we are moving the unit. Now we can call this method from different places and provide false, and then we're going to know that it was not manually moved, but it was moved as part of the state machine. Now if we go back into our harvester script, we also have this move2 method, but this is a different method. And now instead of moving the actual agent, because we only want to move the agent inside the unit movement script, we're going to change this to basically reference the unit movement script. So we're going to have a reference, unit movement, and we actually don't need the animator because this harvester script will be on our harvester and the unit movement will also be on the harvester. So we can simply say get component, and then we're going to say if unit movement script is not null, then unit movement move2, and this move2 is basically this move2 inside the unit movement script. You can also change this to a different name, but it's fine. We're going to provide a target position, and also this time we're going to say false because it's basically an AI command. And what do I mean by AI command? When we call this method inside the harvester, we call it from the going to harvest state or going to supply center state. Both of these are happening automatically and not because we are clicking on something. This happens because we assign a node, or maybe we assign a supply center, and then the harvester, let's go here. The harvester knows to go to the supply center. So because he knows to go to the supply center, he will move automatically, okay? So this is why we have a difference between AI command, or so not AI command, but automatic via state machine. So now, when we receive this false inside the move2 method, the one that is inside the Unity movement, we can also perform a different check. And over here, we're going to check if is player command. So if it's the player commanding it, then we're basically going to cancel the harvesting, right? Because if we command the harvester to move to a different place and it was manually made by the player, then we're going to cancel the harvesting. So we're going to have a reference to the harvester. Then we're going to check if it's not null. And we also want to check if it's actually inside the assigned node. So harvester assigned node is null if he still doesn't have an assigned node, or that vector distance, and we basically check if the harvester is not on the node, if he's still moving towards the node. So we check the distance between the position and the assigned node, and then we check if it's bigger than 1. We can play around with this later on, but when this is all true, then we're going to cancel the harvesting, and we need to create this method inside the harvester script. We're going to set the assigned node to null, and we're going to change these bools. Okay, and we need to set these bools so the state machine will actually react accordingly. Now we still need to do a few changes inside the actual state machine, but we're going to do this a bit later. For now, we want to be able to click on the node while the harvester is selected. And if we click on the node will be assigned as the node of the harvester. We also need to check if we are only selecting the harvester or if one of the selected units is a harvester, right? Because if we select a harvester and a unit, we don't want to allow this interaction. So for this, we're going to open our unit selection manager, because here we do all of this logic to select different things. For example, when we attack something or when we click on something. So at the end of the update method, okay, we are going to copy this entire thing, this attack target, the one that we had before, just so it will be easier. We're going to add some kind of comment. And obviously we need to do a few changes here. For example, we don't need to check if we have at least one offensive unit. We need to check if we have a harvester selected or if we only have harvesters. So we're going to create a different method. It's going to be only harvesters selected. And this method is going to be a new method here. Private bool, it's going to return a bool, only harvester selected. And inside we're going to check if the selected units are only harvesters. If unit selected count is 0, then let's just return because this is not relevant. But then we loop over each unit that is selected. Okay, so basically loop over all the selected units, and these selected units are basically all the selected units at this point. And then if at least or even if one of the units is not a harvester unit, then we need to return false because we won't be able to assign a node, right? So only if all the units are harvesters, or at least one harvester, but we don't have any non-harvester units, then we're going to return true. But if we have, let's say, a simple unit or a tank or something like that, then it's going to return false. And this entire method is going to return false over here. So this is one of the conditions. And we also want to check if the count is bigger than 0. Obviously, we want to select something. Then we're going to have this raycast hit. We're going to send a raycast. And then we're going to, this should be the same. This time we don't want to check for a specific layer. Instead, we want to check if we have a resource node script on the object, right? Because we want to check if we are hovering over a resource node. So if we don't want to check for specific layers, we can simply check if there is a script attached. But the problem is that our resource node is a trigger box collider. And if we're going to add another box collider that is not trigger, our harvester will not be able to move here, right? It's going to be stuck. But in order for this raycast to work, we need to have a collider that is trigger. For this, we can do a small workaround. We can do this all 0 and then query trigger interaction collide. So by doing this, we basically say that we want to apply it for all the layers. And we also say that we don't care that it is trigger. We still want to use the raycast. Okay, so this is a small workaround that you can do. And now we are going to be able to detect this object, and we're going to be able to detect if it has a resource node on it. And we're going to do this by checking this we don't need. Resource node, hit, transform, get component, resource node. And then we can check if resource node is not null, then it means that this object that we are pointing at has a resource node. We're going to place all of this inside of this if, and now we're going to check if we're actually clicking on the button, on the right mouse button. And if so, we're going to set the transform to be the target. Then we're going to loop over all the units that we selected. But this time, instead of this, we're going to assign the node to the actual harvester. So if one of the units is a harvester, then we're going to take the harvester script, assigned node, and we're going to set the target to be the assigned node. So the target is basically the node, right? So we can also rename it to node. And this way, if we have several harvesters selected, we can assign the node to all of them. And although we already check here if we only have harvesters, so even if we have tanks and we don't use this, it will still work, and theoretically it will not be a problem, but it really depends on your game design. If you add this check over here, you will only be able to assign a node if only harvesters are selected. So if you have another unit inside the selection, then all of this won't even be relevant. So you can decide to use this, not to use this. Eventually it will only assign it to the harvesters, obviously. We also want to remove this check over here, this attack cursor visible. And now we have this entire raycast over here. This should be at the end of the update method. Okay, this if, and then after this, we also set the cursor selector. but now we are going to be able to assign a node to all the selected harvesters. So now that we have this logic in place, we also want to change the state machine a bit. We're going to find our harvester and we're going to click on the animator. First of all, we have this transition here from any state to idle. This can be problematic because it will keep doing this if there is no node assigned and there is no reason to do this transition endlessly. So instead, we're going to delete this transition and we're going to create a transition from all the other nodes back to the idle. So if the harvester is harvesting and he has no more nodes, for example, the node was destroyed or maybe the node was depleted, then it's going to go back to idle. So here we're going to set has no node assigned false. We also want to go back from going to harvest, has no node assigned false, from depositing, right? Maybe the node was destroyed, he went to deposit the resource and then he has no node to come back to. So it should go back to idle. False. And also from going to supply center, maybe something goes wrong, maybe somewhere he gets attacked. So again, go back to idle. So basically, each one of these states should have a transition back to idle and the condition should be has assigned node false. Now we also want to deal with a situation where, for example, the harvester was harvesting and maybe he got some resources and then he was attacked and he moved somewhere. Or maybe we manually moved him somewhere, or maybe the resource node was depleted while he still has some resources on him. We do want to allow him to go back into the supply center and deposit the resources. So basically we want to click on the supply center and the harvester should just go and deposit all the resources. For this, we're going to create another bool over here and we're going to name it is not empty because we want to check if he still has something. So there's a difference between is full and is not empty. Is not empty basically means that he still has some resources on board, right, on the harvester. And we're going to set this as a condition for when we click on the supply center and the harvester basically goes and stands inside the supply center. Because if we take our supply center, we have this area over here, and if we expand the prefab, we can see the supply drop. So the supply drop is a small area where the harvester basically goes and drops the supply. When the unit goes and stands inside, we want to check if it has some resources on board, then simply deposit them. Okay, so we're going to add a transition from idle to depositing, and the condition will be at supply, so he's at the supply center, true, but also if he's not empty. Because if he's standing at the supply center but he has no resources, there is no reason to deposit anything. And then if he has an assigned node, he will go back to harvesting. If he doesn't have any assigned node, he will go back to idle. Now if we go into our harvester, we can see this logic over here, this on trigger enter and on trigger exit. And the way we check if he's in the supply center is not with the actual tag, but because we already have a reference to the supply center, right? We have this reference here. When the supply center instantiates the harvester, it gets this reference. So then we can simply check if we are entering into this trigger zone and the object is the assigned node, then we are at node. If it's the supply center, then we are at supply, okay? And we also have these debugs. We can remove them if you want, but this way we can check if we are at the supply center. I don't know if we really need this layer over here, this node layer. Maybe we should remove it. Let's remove it for now because we don't want to be able to click on the supply center and it will think that it's a node because it's not a node, right? Now we're going to save the supply center and remove the prefab. Another thing we want to do is if the node is depleted, so if it doesn't have any more resources, we want to destroy it. And this way our harvester will lose the reference to the assigned node. So this is what we want to happen. If the resource node will be empty, but there will still be a reference, he will just go and he will stand there and it will do nothing, right? This is not what we want. We want to destroy the resource node when it's basically depleted. So we're going to open our resource node script and inside we're going to check when we harvest if is depleted, then simply destroy the game object. And this will destroy the entire node and the harvester will lose the reference. Now obviously you can also keep it permanent and add like endless resources so it will never be depleted. Or maybe you do want to have some kind of limit and then you're simply going to destroy it. Or you can do whatever you want. Now at this point, all of this should work. Oh yes, I forgot, before we can even run this, we did assign and created this is not empty and we did create this transition, but we never added the logic. So inside the harvester, we are not triggering this anywhere. So over here, we need to add this. And we're going to add this the same way inside the update method, inside the harvester script. So it will take the animator and it will set this bool. The same way it will set these bools. So this time is not empty. And we're going to use this way to basically calculate. We're going to check if the current capacity is bigger than 0. So if the current capacity is bigger than 0, then it will be true, right? This entire statement will be true. And then is not empty will be true. If this will become false, then this bool will be false. And now that we have this logic in place, we can save everything. So now we can build the command center, we can build the supply center, and we can select our harvester. We can also see that it has a supply drop assigned, but it doesn't have an assigned node. If we select the unit and we click on the node, nothing will happen. But if we select the harvester and we click, it will automatically assign a node and he will start with this entire harvesting, depositing loop. He will reach 10, the max capacity, and he will go to drop the resources. Now, if I click anywhere else, it will lose the reference to the node. It can be a bit confusing because none and node are very similar, but now he has no node assigned because we clicked somewhere else. We still do have some resources on board, so we can simply click on the supply center and he will go and start depositing it. We can also see that he's depositing. And now, when everything was deposited, he goes back to idle because he has no node assigned. So we can click on the node and he will start it all over again. So everything is working.
Agreed. As you wish.
We can reassign the node and he will continue.
Agreed.
Or we can manually let him go there. So all of this is working. Now the next thing we want to do is create a cursor for when we hover over the node, right? Because at this point, we don't even know that we can gather this, right? It looks the same as just moving. So for this, we're going to change a few things inside of our cursor manager. So we have it over here. We have all the cursors. We still don't have the gathering cursor. So we're going to add a new cursor reference, so gathering cursor. We also want to add a cursor type, this enum, gathering, and we also want to add this into the switch. And obviously you can do the same thing for when you want to deposit back into the supply center. You can create another cursor. So maybe we're going to do this later in the series when we have some free time and we don't have anything to do, but you can do this on your own when we hover over the supply center with a harvester and we want to deposit something. You can do this, but for now we're not going to do it. We're just going to do it when we hover over the resource node. So now that we have this, we can go into our unit selection manager and we need to add this over here. Now, I don't like the way this is built. This is kind of confusing and I just don't like it. I want to change the entire way we are changing the cursors. So instead, we're going to comment all of this out and we're going to move all of these into specific methods, okay? We're going to have this cursor selector. We're still going to have it, but we're just going to create a different version. Inside, we're going to try all of them, and when we actually succeed to do one of them, we're going to return, and it will basically set the cursor. So if something, then return, and we're going to do this for all the different types. We have about 6, 7, right? 1, 2, 3, 4, 5, 6, 7. So one for each cursor, okay? So we have 6 and we also have the 7th one, which is the default one. So inside we want to create a method for each one of them. So 6 and then the default one. So if all of them will fail, it means that we can set our default one. Cursor manager instance, set marker type, cursor type, none. Okay, so if all of them will fail, it will set the default one. So it's like doing else over here. This is exactly what we're doing. We're doing else. But then instead of doing else if, we're going to do it like this. If one of them is going to succeed, we're simply going to return and we're not going to do the rest. So now we simply need to take all of these and add them into specific methods. So we're going to create these methods here. Try set selectable cursor, try set cell cursor, try set attack cursor, try set unavailable cursor, try set gathering cursor, and try set walkable cursor. Now we're going to generate all of them, so simply generate method, and each one will basically return a bool, and when we return true, it will return. If it returns false, it's going to try the next one. Okay, so it's going to try each one until one of them is relevant. So we're going to add this logic inside the try set walkable. It's not the same order, it doesn't matter. Inside the try set walkable, we're going to basically do what we have here. So we check the units count and we also check if we're hitting the ground layer. This is what we are doing. We don't need to do this for each one. We don't need to create an array for each case. we basically want to check different layers each time, right? Or maybe a different condition. So all of these conditions will go into these methods. So over here we check if unit selected count is bigger than 0, and we're going to have a method that will do all of these raycasts. So we're going to create it here, private bool ray hits, and it's going to receive a layer mask, because each time we want to check a different layer mask, out raycast hit, and then we can use this method here. We're going to provide the ground, right? Because the ground layer is the one for the walkable cursor. And we also need to insert this out, but we can use this underscore to basically tell us that we don't care about the output, because we're going to return true or false based on this ground, okay? We don't care about the hit itself. So we're going to set, so if this will be true, if we have more than 0 units selected, and this will return true. So if we hit the actual ground layer over here, then we're going to set cursor walkable, right? And we're going to return true. And if this will be false, then we're going to return false. So if we return false, it will simply move to the next step. Now for this to work, we also need to create a raycast here. So we only create the raycast once and we use it inside all of these. We don't need to create a raycast each time. So inside this ray hits, we're going to create a ray camera main screen point to ray, input mouse position, and return physics raycast. And we want to check the actual mask that we provided. We also want to set this ray to infinity, so it will not be limited to a certain height, mat f infinity, and we're providing the mask. So if it will hit and find this mask, in our case ground mask, then it's going to return true, then this will return true, and then this entire condition will be true, and it's going to set the walkable cursor, okay? Now we're going to do this for the other ones. For example, this one, we're going to do the gathering in a moment. Let's do it for the unavailable cursor. So it's basically the same thing. We just copy this entire thing over here. And we're going to check if the count is bigger than 0. And this time, constructible, right? Because we check if we hit the constructible layer. And this is exactly what we have here. Unavailable, constructible. We check if we hit this layer and if we have more than 0 units selected. So that's exactly what we're doing here. Set marker type, this time it's going to be unavailable. Now we're going to do this for set attack cursor. This time we still want to check the unit count, but we want to use this at least offensive unit selected. We want to make sure we have at least one offensive unit, and we also want to still use this ray hits to check if we have an enemy. And this time we're going to set it to attackable, okay? And let's see, okay, and now let's go, and now we're going to set the cell one. This time we want to check something else. We want to check if we are in cell mode, resource manager. And if we are, we're going to set the cell one, the cell cursor. right? Because this is what we are doing here. We're checking if we are in cell mode. And now we also want to set this one, the selectable one. For this, we only want to check selectable if we're basically on this clickable layer. So again, we only want to check the raycast. This time, clickable. Okay, and we're going to set the selectable. Now for the gathering, we're going to do the same thing. We're going to check if we hit the actual resource node. So we don't want to check any kind of layer. We want to check if it has a resource node. So we're going to do it like we did over here. So it's going to be a bit longer. If unit selected count is bigger than 0 and only harvester selected, then we're going to create this raycast. But because we don't want to just supply a layer, right, like we did here, we cannot use this. We need to create another raycast. Basically, copy this thing that we created here inside the update method. Now we also need to create the actual, so this is not going to work. We're going to create the actual camera main screen point to ray, and we're going to provide the input mouse out raycast hit. So this is all one long condition. We're creating the raycast. We're providing the actual origin of the raycast. We have this comma, then we have this hit, mat infinity, and also we want to allow it to detect items without a collider or with a collider that is set to be triggered. And if all of this is true, we also want to check if there is a resource node script. Then we're going to set the gathering cursor, and we're going to return true. And if all of this is false, we are going to return false. So all we did here is basically checking it the same way we did here, but here we're actually doing this to be able to assign the node. Here we're just doing this to set the cursor, okay, to this gathering cursor. Now that we have all of this logic, we can basically delete the cursor selector, the one that we had before, because we don't need it anymore. And now we have all of these separate methods that do the same thing, and it's a bit more efficient. But we still don't have this gathering cursor, so we need to create it. And you can use your own assets, whatever fits your game. I'm simply going to duplicate the attackable cursor, so Control D, I'm going to duplicate it. I'm going to rename it to gathering cursor, and if I enable it, you can see that it looks basically like the attackable one, but we're going to give it a different color, maybe this yellow one. And again, you can find something better for gathering. We're going to use this one for our demo, but now we have this gathering cursor. We can disable it, and we need to edit it as a reference over here into the cursor manager. So now it's going to basically use it the same way it uses all the rest. And at this point, it should work.
Reporting.
And not the unit, right? If we hover with the unit, nothing will happen. But if we select
Awaiting orders.
the harvester and we hover, we can see it. Now it's going to be problematic because this is yellow and this is yellow, but you can see that it's being activated. It's just hard to see it because of the color. We're going to change the way this node looks. Okay, I don't want to make this episode too long, but you're going to find a link in the description for some kind of puddle, and we're going to make this node into some kind of oil puddle. So this will be the resource. It's going to be some kind of oil puddle. You're going to import it into the project. It's going to be like this. You need to make it into a sprite, apply, and now you're going to see the puddle. You're going to drag the puddle into this node. Now make sure that it's going to be 111. Okay, so change the node to be 111, disable the mesh render, and drag this oil as a child. Now we also need to change the position to 0, 0, and rotate it to 90 on the x-axis. Now you can see that it's not nice, so we're going to move it up a bit. Okay, so now it will be on the ground, but it will not intersect with the ground. And it's kind of big, so we're going to make it smaller, 0.3, 0.3. Now again, you can use whatever fits your game. This is just so we have some kind of nice looking resource node. So we can rename this entire node to be oil node or oil node. Now we can do more with this. For example, we can add some code into the resource node. If the resource is getting depleted, we can maybe change the scale accordingly, right? Maybe we can reduce the scale as the resource is getting smaller and smaller. Maybe we're going to do this a bit later in the series. You can remind me in the comment section, so I will remember to do this a bit later. But we can change the size based on the actual amount of resources or something, or you can just leave it this way until it's actually destroyed. So now that we have this, it's going to look a bit better. And we can create this harvester, and now we can see that it changes the color to this yellow color.
Awaiting orders. Agreed.
And we can click and it's going to start harvesting. Now we can add another animation, maybe some kind of sound, maybe an animation that your harvester is moving. And you can add this animation inside the harvesting node over here. So we will know that it's actually harvesting and not just standing there, right? We can also add some sounds when it's depositing, maybe also make this harvester move. We cannot do this because this model is very static. It doesn't have any way to move any part of it, right? Yes, we don't have any way to move our model. It's just a body. But you can add some kind of indicator to know that it's actually doing something. Now in the next episode, we're also going to add a bar at the top of the harvester to know what is the capacity of the resources. So we will know if it's full or not, so the player can know if the harvester has some resources on it, okay? But this episode is getting very long and there's a lot to do, so we're going to continue with this in the next episode. Thank you for watching. Please subscribe if you're still not a subscriber. You can leave a like, you can ask me something in the comment section. You can also become a member of the channel to get access to our Discord server. And I'll see you next time.